Hello viewers, welcome to this video lecture. This is the second part of power performance of vehicle in which we are going to discuss diagrammatically about the resistance of motion which occurs during the vehicle motion. There are few type of resistance which act during the motion of vehicle. The first one is resistance offered by roughness of pavement and deformation of pavement, which is known as your rolling resistance. The second one is offered by air and it is known as air resistance. Third one is denoted by Pi and it is related to your gradient resistance. Pj stands for resistance due to inertia during the acceleration and deceleration, and where P small p related to your transmission losses. In this diagram that starts with a surface road having no gradient. This is our vehicle which is moving in forward direction. If this is moving in forward direction, so there is a friction force act between the tire and the surface of pavement, which is equal to your rolling resistance, and this rolling resistance is the multiplication of weight into friction coefficient, or this is the coefficient of rolling resistance. This PF act in this direction. Next one is air resistance. When this vehicle moves forward, the frontal and the side bottom of the vehicle and the tire and the back side will feel some air resistance, and this air resistance will denoted by PA, which is act in opposite direction. Now there is a last one, that is PP, which is transmission losses. That transmission losses, suppose if the power produced by engine is P naught. The power produced by engine is P naught, and the power delivered to the tire is P2. So the loss of power will be P naught minus P2. This P naught minus P2 is equal to your transmission losses. Generally this transmission losses is taken as 10 to 15% of P naught, where this PA is equal to coefficient of air resistance multiply with frontal area of vehicle multiply with V square, which is velocity of vehicle. So in this figure we cover our rolling resistance, air resistance and transmission losses. Now we are moving to another two. The first one is gradient and another one is inertia. For this purpose we draw another diagram. Suppose this is point number C and D, and this is your vehicle. At this section, let's take this section. The velocity of vehicle is 10 meter per second. But after D point, there is some gradient, longitudinal gradient in pavement, due to he want to increase his speed to 20 meter per second. At D point, the speed of vehicle will be 20 meter per second. So there is an extra work done by the engine of vehicle, which is known as acceleration produced by the vehicle. This acceleration is equal to your change in velocity with respect to time. So the change in velocity is v minus u, which is equal to 20 minus 10 meter per second, and change in time duration between the point where it is moving with 10 meter per second and point D where the vehicle moving with 20 meter per second. Let's take this time as t and assume this time as 2 seconds. So in this figure, the acceleration which is produced by the vehicle in the form of extra work done is equal to 20 minus 10 divided by 2 seconds. This extra work done is given by your inertial resistance due to acceleration, and the value of this is m into a, where a value taken from this point and m value taken from the table according to vehicle classification. In case of deceleration, suppose let's change another. Suppose initial velocity is 20 and the final velocity is 10 meter. In this case, the acceleration will be 10 minus 20. Hence, this is a negative value, and negative value shows that there is a deceleration occurs here. In this case, the Pz will be negative m into a. Now understand. Now we are going to understand our resistance offered by gradient. Suppose this is angle theta degree. So tan theta will be this height upon distance between DE. So tan theta will be h upon DE. Since the longitudinal gradient provided in your road is very small, hence we can say that tan theta will be equal to your theta degree, and it is equal to your height or rise gain to the horizontal distance. It means that if the sine theta is equal to theta, then we can say that it will be equal to sine theta upon cos theta, as we know that tan theta equal to sine theta upon cos theta. But the rise gained by the vehicle is very small as compared to the horizontal distance it was traveled. We can say that the sine theta is equal to theta, and cos theta, because theta is, if the theta is very small, then cos theta tends to equal to your 1. This is all about little bit introduction of the gradient. Now I provide a vehicle which is moving toward uphill, so the gradient in this figure will be inclination, or we can say the gradient in the figure is positive gradient because the vehicle is going to rise. So the Pi is given as potential energy, which is equal to weight into height. According to this figure, the height will be h, hence the Pi equal to W into h. Since we know that the height is equal to your sine theta, and the sine theta, because the theta is very small, hence we conclude that it is equal to your theta. So in this case we can say that Pi is equal to W, h is equal to W sine theta is equal to W theta. We all know that if this is the weight is the force, this will be divided into two portions. The first one is W cos theta, which is perpendicular to the surface, and another component is parallel to the surface, which is W sine theta. So this extra weight need some extra power to pop up this vehicle for a higher gradient. This extra power is termed as gradient resistance. So this is all about the diagram of all the resistance which is offered during the motion of vehicle. So we complete the diagram of all the resistance. Now what we are going to do, we are going to define our EP. This is capital P. This is the power generated by your vehicle. That is the maximum power generated by vehicle, which is equal to your summation of all resistance, like rolling resistance, air resistance, plus minus gradient resistance, plus minus inertial due to acceleration and deceleration, and plus transmission losses. But for positive side, you need to take positive value of your acceleration and positive gradient resistance. This will give the maximum value. So we need to find this power so that it can be produced by vehicle to cope up with all these resistance. Thank you and have a nice day.